Hey folks, as always, we hope you've had a fantastic week. For Blocktober, the month-long celebration of level design in games, solo developer Gwen Frey shares the evolution of the newly released 3D puzzler Kine, from core concept all the way to shipping. In her write-up, she covers 4 distinct phases of development, with insights from each phase that may help you in your own dev cycles. Check out the blog and accompanying videos. Between stringent regulations and months of laborious training, getting expert ground crew and mechanics up to speed isn't easy for the aviation industry. US-based Inlusion, along with FL Technics and Baltic Ground Services, aim to ease the burden with regulation-perfect VR training that eliminates the danger of practicing on real aircraft, saving time and money in the process. On September 25th, over 300 professionals from the architecture and engineering and construction industries convened for the biggest Build London for Architecture event yet. The speakers showcased and discussed innovative ways real-time technology is being used for AEC projects, including digital twins, immersive design, urban planning, and data visualization. Get a full recap on our blog today. And now for our top weekly Karma earners: MM Crewdimer, Clockwork Ocean, Shadow River, Crisp Clover, Thompson N13, Lord Stuff, Pasity, T. Sumisaki, and Adno. These lovelies have been helping folks out on AnswerHub, and thank you all so very much. All right, it's time for our spotlights. Here we have Flingwin Station, a casual projectile endless runner. Your goal? Save the penguins by rediscovering the secret of flight. Fly as far as possible, level up, upgrade your penguin, and customize him to your liking. For our second spotlight, you'll see a VR realization of transportation methods from the past built for Vienna's public transit company. The models were created based on hundreds of pictures of the actual real-world vehicles and then worked into a guided virtual tour. Inspired by popular titles Risk of Rain and Faster Than Light, One Last Planet is a 2D action platformer sprinkled with narrative decisions and RPG elements, with difficulty that ramps up as time passes. Fight enemies and monsters on the ground and in space today on Itch. Thanks for tuning in. We'll see you all next week.
Hey everyone, and welcome to the Unreal Engine livestream. I'm your host Victor Brodin, and today I've got Chris Gagnon here, lead editor programmer on the engine team, and we're going to talk about subsystems.
Awesome, thank you very much.
Nice to have you here. Happy you were able to take some time out of your day to prepare a little presentation for us.
Yeah, we'll do a bit of a slideshow here, and then we'll jump into a code example, and then probably do Q&As. Subsystems aren't that complicated, really, so it should be relatively quick.
Hopefully, we'll see with the questions, and we'll try to answer all of them as we go and do a bigger, more QA at the end.
Okay, awesome. I got a slide deck up here, and we'll just kind of talk about what subsystems are. So basically, subsystems are automatically instance classes with the managed lifetime. So it's kind of a bit of a mouthful, but we'll break it down a little bit. So automatically instance means exactly that. They're just automatically created for you. The instances of the class are created for you automatically. And the number of instances kind of depends on the lifetime you choose, and we'll kind of get into that later. But basically, you don't have to build the infrastructure to create the instances of your class. That's kind of part of the value of subsystems in general. And then their lifetimes are managed. So depending on which lifetime you choose, and we'll get more into that, but you will be created automatically. You will get initialized and a deinitialized along with that lifetime that you've chosen. And as I mentioned, multiple instances will be created, if that makes sense for the subsystem type. So let's dive into kind of like the next things, like what are those lifetimes? So the lifetimes you can choose, and I've kind of broken into two different groups here. There's game instance subsystems, local player subsystems, and world subsystems. So those are all kind of your game-centric subsystems for the most part. And then we also have editor and engine subsystems, which most people probably wouldn't use that much unless you're doing extensions to the editor or really low-level engine sort of systems. But they exist, and they do have utility. So these are the lifetimes we're talking about. So when I say a lifetime, let's take game instance, for example, here. I'm going to create my subsystem. It's going to derive from you game instance subsystem. And then when game instances are created, your subsystems will be created along with it. They will be initialized and then deinitialized prior to the game instance being destroyed. So that's what the managed lifetime is all about. And this is just really nice because you don't have to worry about, well, where is the right place for me to initialize or deinitialize my subsystem? You don't have to worry about deriving from the game instance subsystem to, from the game instance itself to add your subsystem internally, which is something you'd commonly have to do if you're working in C++ to add those types of modules or systems into the engine. So we'll probably get back to a lot of that stuff, but I think we'll just kind of jump to a code example here to really kind of show it directly in place. So I've built a little example. I did this kind of yesterday, so apologies if there's any typos or anything silly in here, but it's really as simple as this. I've created a new class. So basically, in this particular case, I just started with the first-person template. And I was like, okay, well, what do I want to do? I'm going to make a score subsystem. So I decided that I wanted to have a small system that would basically, keep track of your score. I had a bit of a concept of like multipliers in here, and then I went ahead and kind of built something out of this. So just to kind of give you a sense of like what is required in the code, it's really this right here, right? You are creating your new class. You're deriving from one of those lifetime classes. So all these other classes, so UGame instance subsystem, that's just part of the engine now. UWorld subsystem, just for clarity, is actually a new one. It's not in 423, but will be in 424. So I've now inherited from this. I have a couple simple functions I can override here. For the most part, you don't have to do a whole lot with like this parameter. So this is given to you for some other complexities. We can talk about those later. But for all I really did was like I took my initialize. I initialized a couple of variables I keep. Deinitialize, I cleared out some delegates I had in here. So really all I provided was a bit of API for incrementing a multiplier, adding score, and getting the total score. And then I had a couple events that I declared here. So one is for when a score is at a particular amount of score. So you do something that gives you 100 points, this function will get called. And then we also have another function for when the score changes. So and this kind of like gives you anything can happen that could change the score and gives you back the total score. So those are the two events I put together. Now as you can see, like the code is extremely simple. There's a couple things for increment, adding score, and then this is where our events get called. So I call both of them. The idea here is that maybe in the future this becomes more complicated. There's more factors in my score system, and that's why I have two different events. Also, the use case of them are slightly different when we look at the other side. So in general, I've created an extremely simple system here. And if we jump over to the editor, oops. Shift O. Nope, is that not a keybind here?
Looking for the content browser?
Yeah.
It's on third tab there.
Perfect. So, and we'll just take a look at something called simple score target. So, the thing that the subsystems give you on top of the fact that you don't have to create that wrapping code to create it and manage its lifetime, you also can get them in blueprints very easily. So we've created a bunch of custom nodes to do that. So if we just zoom out here a little bit.
You didn't have to add any specific metadata?
Nope. Just deriving from that class is enough. We use basically the Unreal Type System for detecting derivatives of those key classes, and then we basically factory up all these accessor nodes. So like for example here, I have the score subsystem, and I've called those add and increment. And we can kind of go through this blueprint more later, but I just want to show that. So if I right click and I say, where currently, we'll just, oops. Just stop by so we can. So I just search for subsystem here, and you can just see like game instance subsystems, get score subsystem, and any number of subsystems you might have in your game would show up and be very easy to add this way.
And any actor has access to this, right?
Yes. Well, let's talk a bit more about that.
Okay.
Depending on the subsystem you've created, you need to have the context to understand how to get it. Generally, that context is fairly simple. Blueprints basically always know what world they're in, whether it's a widget blueprint or a regular blueprint. They all basically understand what world they're in, or what, in the case of widget blueprints, they understand what player owns them. But the bottom line is all of those can easily get at the kind of a global context and understand how to get at their subsystems for most things. So for example, the game instance, I mean, there's only one game instance, sort of, and that's why subsystems kind of help you. So there's only one game instance as far as your game goes. But if you're in the case of the editor and you're actually doing multiply or something like that, it's actually more complicated. There are multiple game instances. There's one per kind of running sub-game inside the editor. So that's one of the reasons why these types of things kind of help you out. These are the types of complexities you don't have to worry about. But they have enough context to know what game instance they're in. They have enough to know which world they're in. So getting a world subsystem or a game instance subsystem is really simple. Local player subsystems, those ones are a little bit more complicated in that there might be multiple local players, right? If you had a local multiplayer game. And in that case, what it does is you have to just pass it in like a player controller. So local players aren't actually a blueprintable class. So you don't really have access. Those are kind of a bit more of an underlying thing. But they have a nice simple lifetime, and they only exist on the client, so that kind of simplifies a lot of stuff. So, but we can always map to a local player from a player controller, which you can get in Blueprint. So in the case of a subsystem that you put on a local player, you would simply, be like, get my subsystem that lives on a local player, and you pass in the player controller as kind of like the context it needs to be able to find.
I think
that
we
thing.
even had a screenshot of that in the documentation and the announcement.
Exactly. The documentation kind of shows all of them. It doesn't have anything for the world stuff right now because, like I said, that's kind of new in 4.24. But yeah, it gives you an example of some of those different ones. But for the most part, it's really simple in blueprints to get and stuff. And it's really nice because, and one thing that we'll see here with this example is, this, for example, this simple score target is literally a cylinder I made that does some stuff. It's like a target. We're going to shoot it in a minute when we play the game. But the other thing I've done is we can just kind of minimize that guy for now and say over here, I made a little HUD as well. So if you take a look at this HUD widget, basically this guy has a couple of text blocks. Believe me, it's not going to be that impressive. But again, so this guy, what he does is he actually listens to those two events we had. So the score, we register the score subsystem for the on-score change, and this is where we update our total score text. Here, we did something a little bit more complicated, but basically we register for the score added event. We grab the score subsystem to bind that event. When the event gets called, we get the multiplier because I basically build a little, you guys can see that, a multiplier times score, sort of formatted text, and then a little bit farther down, I color it just for fun. So the idea is that, I have this subsystem, and it wasn't on a particular actor. One way of doing this would make a particular blueprint that would manage all this type of stuff, and then you throw that into your level or something like that. Now, not only do you have to remember all my levels have to have that particular actor in it for my game to function properly, but now everyone has to get at that actor. So maybe you have like a static blueprint library that remembers it to make that easy, or you're looking up an actor by name. All these types of things that are more work, first off, and also just a little error prone. So
you have to remember and do it every time, right?
Exactly. And so what a subsystem gives you is once you've defined the code, you're kind of already in business here, and it allows you to really encapsulate that functionality. Subsystems are relatively new, so there's a lot of things in the engine that honestly would be better represented as a subsystem. Like if you look at game instance, you'll notice that there's a bunch of stuff about replays, and there's a bunch of stuff about a number of different other things. And like in the end, it's like, wow, this would be a lot cleaner if we took those things and separated them out into different subsystems. And maybe we'll do that over time. But the idea being that if you're starting fresh from a game, especially if you think in the terms of these are my different subsystems, these are the different encapsulated pieces of functionality I want, can really help you organize your code really well. It does require C++ to use subsystems. We don't really have a way of defining a subsystem directly in Blueprint right now. But that said, like if you're doing it in Blueprints, you could use Blueprint libraries and things like that. But that's what subsystems are kind of meant for. But the idea here is that in C++, which has benefits over Blueprint, right? It's easier to write code. It's more performant. It's generally easier to debug in a lot of ways. The iteration time is slower. That's where Blueprints definitely win out. But oftentimes, when you're developing a lower level system, the things you iterate a lot on are the stuff you're seeing in this blueprint, right? What does my layout look like? What is my text going to do? What effects are going to happen? Animations. Those are all things that happen off of events of my subsystem. So in my particular score subsystem here, I basically said, okay, well, I have a very relatively simple score calculation. I have a number of accessors and mutators for that, and here are the events that tell the rest of the world about things that are happening. So not only have I created good event-based code where I'm not ticking and polling for things or doing anything, kind of bad for performance in that sense, it's also just kind of, you've set it up such that on the tail end of all those events that you expose, and this is kind of just good programming in general. I've exposed those events where now people can iterate for days on the look and feel and stuff like that. But that all happens kind of, in blueprints where that's really good for iteration, but that core code is very protected kind of thing. It's kind of set in stone, which it will change over time, don't get me wrong, but the rate at which that changes is often much, much slower than, say, the blueprint type stuff. So not only have you set yourself up for good performance and easy debuggability of what might become a very complicated system over the lifetime of your game, but you've kind of really split the line there of, hey, here's where all that kind of like the look and feel and it's like niggly stuff is, and here's like that core system that has a set of rules, right? This is the API that you can touch. These are the events that occur. And you just set up event-based stuff, right? So now all that other code that's dangling off of it doing stuff is now event-based, and you're not worrying about the performance implications of that. Obviously, if you have a game that starts doing score every single frame, maybe then we have to go back to our system, think about deferring things and doing other performance stuff. But that's kind of like next level, right? The idea here was simply like all that's in one place. And then if you think about it on the larger scale, out of a whole project, an entire game, you have many subsystems, and they can all kind of talk to each other, but it really helps you encapsulate that code very, very well. And there are there's very few subsystems shipped with the engine right now. One, for example, and we didn't see it, if you'll notice, when I pulled up the context memos, because there's an editor subsystem for plugging into asset importing and exporting. This is obviously kind of off on the side, but that's another subsystem we have. And if you use editor utility widgets, you would see those, you'd right click and try to add a node, and you would see the import subsystem there. It's just filtered off because it's editor only, but we do have minor use of it in the engine, and that will continue to grow over time. Subsystems are still relatively new, but they're definitely meant in a lot of ways for people writing a game to be like, hey, here are my key systems, let's encapsulate those and keep them sacred, as it were.
And they're in full release, right? They're not in a beta stage.
They're full release, yes.
Yeah, that's what I thought.
Yeah. I mean, it's one of those things that there's not a lot to them in general, and that might grow over time, or we might add more lifetimes that you might be able to register to. Though I think we've hit the big ones so far, especially with the addition of UWorld, which was a pretty important one that didn't make the initial release. So we're happy to have that one now. And then kind of the one extra thing, so let's just kind of quickly go back here. Since we're talking about like the deep use of them, we'll just kind of go back to I'll just make sure I don't.
Yeah, and I think that's it. You need to know the fundamentals before you start diving in and making decisions of how you're supposed to build a framework for your game. So,
for sure.
So I think it's good that we're touching on that.
Yeah, and we've touched on like some of these things. I just kind of have a little list here to kind of remind myself of points to mention here. Where we've touched on a bunch of stuff, right? So it saves programming time. This kind of comes back to I don't have to write all that connective tissue code. And modularity and consistency. That's really about the idea that, okay, well, a subsystem gives me a home for a set of functionality, right? If you were to just put all this stuff on game instance, it ends up being, my game instance has a score system and a save data system, subsystem, and spawning my targets system. Who knows, right?
Yep. And now we have 4 people trying to work on different versions of.
Right. Exactly. And now you have the possibility, because they're all in the same place, everything's accessible, right? Like if you're, a coder who's trying to make a robust system that is defensively coded, you're making a lot of decisions about these are my public pieces of API that people can interact with, and this is my private implementation. I put all those things in one class, and your friend who's writing, the save system might poke into your private data to get something done. Didn't really realize what he's doing. Now he's kind of broken the rules about your stuff, and now you can't logic about the state of your system well. Like, I understand that people are going to call these functions, and these are those things those functions do. Someone else is kind of coming poking in underneath the hood and changing some stuff around. That's a source of bugs, right? So the idea of them being real separate compilable elements, helps protect you against that. The other really nice thing here, and we haven't touched on this yet because we're kind of focusing on games a bit, is if you are trying to make plugins, right? Whether or not it's because you're making plugins that you want to share across your own games, or you're making a plugin to put on the marketplace, or anything like that, it was always the case that you would probably like release some code. Like I have my super system that I've released and everyone's super excited about using it. And there'd be this disclaimer, right? Where it's like, okay, well, yes, download it, add the plugin, then take Magical Actor and put it in the level, or take, instance up one of my, systems managers and put that in your game instance and make sure you call this function on it at this time. There's those things, right? That they kind of come in. Maybe you have a demo one, but then the user's like, okay, well, I already inherit from game instance, so I got to go and figure out, put that code into my game, right? So that's a common thing, right? With subsystems, that's kind of a thing of the past, right? The fact that they've included the plugin means that in our type database, we know of, in my particular case, UScore subsystem. So that gets created automatically. It's just there because they've included that plugin. So it really makes that a lot easier. And because you don't have to force them to put it in, there's just a whole bunch of bugs that can't happen there. People can't mess it up or put initialization in the wrong place or do it before or after calling the super of a particular initialization. All those types of common issues you might have for someone who's just like, oh, this should be simple, throws it in, and then it's like, oh, why does this not work?
Yeah.
And then forum posts and
And
questions.
it also provides something that people might be familiar with, right? So they started with subsystem, they used it once in one plugin, and someone else releases another one. It's like, oh, I know how to get these references.
Yeah.
I know how to run these functions.
Yeah, and that talks about the consistency, not just in your code base, but across code bases, right? Like the idea that, if you generally separate things this way, people understand. It's like, okay, well, I'm looking for some set of functionality. Well, generally, I start with a subsystem. Like one issue that I have in Blueprints is that, I right-click and the node list is very, very long. We have a very, very busy global namespace, right? And that's something hopefully we can improve over time. But certainly, if you're writing your game with subsystems in mind, this very quick filter where it's like, oh, I know how to do everything subsystems. I see my subsystem. I get to the right subsystem, and from there, I'm doing a contextual drop of a function, and I'm not worrying about. Like that's the one kind of thing that Blueprint libraries sort of struggles with, right? Because whenever you create a blueprint, it's real nice because I can get at it really easily.
Yeah.
But now it's part of that global namespace, and it's very, very busy and can be difficult to find things. So
we were mentioning it, adding custom to one of the function names, and the difficulty of then someone who's not familiar with that function accidentally adds that one and just goes, hey, what is this? I'm looking for something different.
Yeah, and like the thing is that because it's consistent on the way to get it as well. As I showed kind of in my example, which we should get into more. But in that example, like I have UI that was getting some information or registering some events, and I also had a number of different actors. I'll show you that I have more than one actor, and it's all very simple. And there wasn't any extra stuff. I only made things for my game in the blueprints, and just that subsystem I wrote over in C++ was just available to everything in a very simple way. So. Just before we move away from this, I guess, is there anything else? I'll mention quickly, I guess, that you can access them through Python scripts as well, which is not really untrue of any other Blueprint stuff. Like as soon as you expose something to Blueprints, it's effectively exposed to Python as well. I'm not sure if many of the people watching will use Python often. It's a scripting language we use in the editor only.
We did a stream a couple of months ago with Aaron Carlisle and Jamie Dale.
Awesome. Yeah. It's a great system for, generally for larger teams or whatever, but people create customizations to the editor. And more with editor utility widgets and our exposure of more stuff, you could start writing plugins for the editor that utilize Python and UMG to create new tools and stuff like that. So it's an area that we're still fairly young in, but we're really growing to try to allow teams and different groups to really customize the editor in a lot of ways. But the one thing that the subsystem gives you is, again, that the ability to access a thing. Because just exposing something to Blueprint doesn't necessarily mean you could get it in Python easily, because you needed to get an instance of it somehow. So sometimes that's the missing glue code, and you get that for free with subsystems as well. So we'll just jump back to the editor here. We can look at these assets later if you want, but I'll just kind of like jump into Py here and kind of show you what I did. So, basically I have the idea here of, I think this is a small amount of score, like 10 score, and this is like 100 score. And this like increases my multiplier. Oh, sorry, this was a loss of score.
You don't want to hit that one.
Yeah. So the idea on this one was like, if you just take a look really quickly over here, this is the simple score guy. Like it's literally a cylinder, and I just hooked into when it gets hit. So you can. My game's obviously not very robust. You can walk a character into these and trigger them as well. Probably not what you'd want in a final game. But all I really did was I exposed a few variables: base score, multiplier, increment, and color, and kind of created so I created a little mid so I can change the color of it. And then I have this thing that's just like, oh, well, if the base score is about 0, I intended it for it to be a score increment. Otherwise, use the multiplier. Very, very simple. And that kind of drives those 3 different targets you saw there. And then I kind of went, and did something a little bit more complicated. Pull that up here. Because it's super complicated, but called it complex. But so in this guy, so very similar logic here. So when it gets hit, it looks at some of the, so I basically duplicated this from the other one and then kind of went and changed it. But basically, this one can actually do both. So it does a sequence and says, okay, well, if I have a valid score, I add some score. Score can be negative, by the way. We'll see in a second. But and then if the multiplier is non-zero, then I also increment the multiplier. So and then I have this idea of a change state. So basically what I do in change state is like I come in, I choose a random number, and then I basically decide if this is going to be a green positive score thing. A purple, I think, is our incrementing your multiplier, and then red is some sort of loss of score, and that one's I used a little switch here to say that that's 3 times as likely as the other 2 individually, and then I basically set a timer again. So and then they basically change between 1 and 3 seconds. So that's what's happening here. And you can see that it's actually running, and that's because if we turn around in our little level here, I've got like a little mini game over here. So, it's like if you shoot the purple ones, the multiplier goes up, and they shoot the red ones, you lose some score, right? So if we do this, I end up back at 0. I can try to get my multiplier a little higher and wait for like a green thing. I can shoot a green, get some score. And then obviously, since they're changing all the time, you mess up and end up back at 0, just like I did. So, there's no connective tissue here at all, right? I've shown you all 3 of the classes I did to make a game, right? I mean, it's not much of a game, obviously, but I have a simple target, a complex target. Presumably, those could have been actually inheriting blueprints that shared some code. I didn't do that here, but they're really simple. And then a very simple widget that gives us this little bit of UI up at the top corner that shows us the score. I mean, there's not much to it, but I didn't have to write a game instance. Really, I didn't have to pass information through my player controller. I didn't have to do a lot of things that you might have to do, if you need to pass data around. And on top of it all, it's completely event-driven. I mean, I'm using a tick, not a tick, but a timer in the actual in this complex one here, just to run this little kind of gameplay logic on these things. But again, that's not a tick, so performance-wise, it's actually pretty good, right? It's only coming in there once every 1 to 3 seconds per target, I guess, circle, little not textured cylinder. So, and that's kind of it. I mean, I think one of the hard things with subsystems is figuring how to use them. Not so much in like the nuts and bolts I just showed you, because that's relatively simple, but I have a game I want to make. It's a game with all these features. What should be subsystems? What should be components? And subsystems aren't a replacement for components at all. Actually, UWorld subsystems that you're going to get in 424 are a great way to pair with a component. We actually talked about an example just yesterday where imagine you're making a racing game and you had checkpoints. Well, checkpoints are a thing that you may very well want a component on, right? They need to live on a particular actor type, and they live, around a world, so they have location, they have other interesting information. But if I want to change, I had a game, you're racing, and I want to, track your positioning, I might want more of a global place to store that, not only because, I don't want the different checkpoints to try to have to talk to each other. They need to kind of talk to a manager to keep track of what's happened and make sure, and it might do arbitration about which one's the next value, like one that's, enabled and things like that, right? And all that sort of orchestration of something that does live in the world, that does make sense as a component, might be better as a subsystem, right? Because those components can very easily be like, hey, get me this world subsystem of type, in this case, our checkpoint subsystem, and say, hey, register myself, or the user just passed through me, whatever. It might then say, oh, go talk to the score subsystem and give them some score, or take some score away, maybe. But the idea being that, this is not a replacement for components, but works very well with components in these cases where, you know, and this is very true of a lot of gameplay. You know, you have a lot of different elements, or maybe even a multi-map, right, where I have different types of checkpoints or different types of actors that all talk to the same subsystem.
Right.
So-
For some reason, they might not even be inherited from the same base component class, right? And then they'd still have access to the same
Yeah, absolutely.
piece of information. Something else I thought of that I was just curious if it might be a good solution for a subsystem would be like a projectile pooling system that would work really well.
Yeah, it could work for that for sure. I mean, this is the idea that, you know, I have a bunch of bullets. Bullets are expensive to make for whatever reason, so I create 100 of them, and then the gun or guns in the game say, hey, I need a bullet because I'm about to fire, and it goes and asks this thing for it. Well, I mean, how could I do that? I could create an actor, right? And I could have that actor have a bunch of children, they're all hidden and whatever. I could do it that way, yes. But then, you know, my gun's like, okay, well, go get me the named actor of my bullet manager, whatever, and then do stuff, and it works. But it's certainly not as clean as me having a subsystem that knows, like, you know, it can even be more generic, and right, where it's like, oh, I'm a pooling subsystem that knows how to pool that actor and this actor. Yeah, so it can do all kinds of stuff. And then you just say, hey, get that subsystem, hand me off one of these things, and then use it, and then you can release it back into the pool when you're done with it. Or that could be the bullet itself might release itself back in, because remember, in that case, it's like I have a gun who might do the acquisition of a bullet. The bullet itself, the gun might not know or care when the bullet hits the thing, but the bullet does. So when the bullet, you know, impacts, does damage, it, you know, plays a particle effect, does whatever, and releases itself back into the pool, right? So now I am already talking about a, you know, my gun blueprint maybe, or my gun class, whatever it is, and the bullet class is both talking to the subsystem. Well, you know, that's where subsystems are really starting to help, right? Like they make that easy, and you know, and clean. So, you know, now I have. That's two subsystems in our game. I got a score subsystem. I got a pooling subsystem. Maybe I add you know, my character customization subsystem where, you know, or, you know, my account subsystem where that I store like what I've unlocked and things like that. Who knows, right? And that's what's hard about making games, right? Figuring out all the pieces you need and that stuff. But subsystems are definitely a tool to help you accomplish that. And they fit well with the idea of encapsulation of one particular kind of set of functionality. So, you know, we've shown a really simple example here, but you know, really the sky's the limit with it.
Right.
There's very little overhead to it. Because they, in the end, effectively work exactly how you do it anyways. They just do it for you. And you know, there's a little bit of overhead to looking it up. So like whether or not you're doing it in C++, like you can, but for the record, you can add all these in C++. So I could write a C++ subsystem that says get other subsystem and then does things with it in C++ or whatever, or a component written in C++ that does the same thing. So they're fully accessible in C++ and Blueprint. But where was I going with that? But the idea being that, you know, there's a tiny bit of cost of looking it up, right? So you get the subsystem and it has to look it up in a map by type, which is pretty fast. If you're in particular code that, you know, you're really worried about the performance of it, you might want to cache that. So like in the initialization of something, I get the subsystem, hold on to a pointer to it, and then access it directly from there on. You have to be a bit careful with that. But remember, one of the things about subsystems was those managed lifetimes. So you know what the lifetime is of a particular type of subsystem. So as long as in your situation you're within that lifetime, holding onto a pointer is fine. They're not going to move around on you.
And you meant grabbing the data from the subsystem and then caching it inside the blueprint that.
I was actually talking about caching a pointer to the subsystem in this case, so you don't have to do the map lookup. We're talking about relatively small gains of performance, but if there's something you had to look up at a very high rate, that might be worthwhile to you. But again, it's just an example of when you might want to concern yourself with the lifetimes of a subsystem. But for example, like, you know, if I had an object in the world that does something, a component maybe, that needed a subsystem, it can probably cache that pointer if you thought that was best performance-wise. I mean, it lives in a U object, it lives in a world, it should live throughout the that lifetime. There's some edge cases of that, so you might need to protect yourself, but those will only be like tear-down cases and things like that, not functional cases, so you might have to protect yourself from it for crash reasons, but basically checking for a null pointer as a return.
Reference,
Yeah, but you'd never really have to worry about that in an actual runtime case, because you're in a world that exists. The only time that it wouldn't work is if you didn't have the subsystem for some reason, which is pretty much impossible in that the fact that you can compile that reference means that the subsystem exists. That's not true in Blueprint, right? Because obviously if I change C++ code, for that code to ever take any effect, I need to be able to compile. And that basically checks the fact that that class is known. In Blueprints, you could have like a blueprint that referenced a subsystem. You then disable that plugin that has that subsystem in it, for example, and now that blueprint won't compile. So that's one way you could kind of break data. I mean, it's no different than you deleting some API you were using a blueprint, but those cases can happen.
And but caching it just simply is basically just getting a reference to the subsystem and promoting that to a variable, right?
Yeah.
And now you have it cached, and that's essentially the only lookup you're mentioning, though.
If you're in Blueprints, I really wouldn't worry about doing that.
Okay.
Definitely not. I mean, you're talking about optimizations that would only make sense in small, very, very tight loops that, and you shouldn't be doing that in Blueprints anyways if you want performance. So if you're in C++, then maybe caching makes sense.
Okay.
I would never worry about caching
yeah.
them in Blueprint. It just it's not worth the gains. So
cool. Let's see. Can take a couple questions, maybe.
Yeah, absolutely.
Yeah, we actually we had a couple questions initially, but we pretty much talked through all of them already.
If there's anything we want to like recover or go in deeper, we can do that too.
Yeah, for sure. Yeah, we definitely got time. Let's see here. Is it ever intended to allow subsystems to follow tick groups, or are they always going to be late in order? In some cases, it would be useful to target a subsystem to an actual group.
So subsystems don't tick on their own, so you'd have to register a tick. So you can basically register whatever ticks you need. Generally speaking, registering tick groups, I'm not sure if there's API to directly register to a tick group from C++. Worst case scenario, you could like route that through an actor that had a tick group specific to it. That's not very nice. That's something we might be able to grow in the future. But a lot of times, if you want to do stuff like that, you can definitely kind of create a, what do I want to say here, like a manager to deal with that. So let's take a step back here. I think that in this particular question, you want to talk a little bit about what your intent is, right? There are cases where I think the user's right. Being in a particular tip group means that you're going to tick relative to other actors, right? Because tick groups are really about when actors do things, right? So being able to kind of input there, into the right place in that stack makes a lot of sense, and I think that's a valuable thing to be able to do. But there's also the question of, well, maybe it's just that I want my subsystems to be able to do things in certain orders. And at that point, you could write code that actually calls a set of functions in a different place, or another subsystem to do it. So you could imagine like having like my, or even game instance could do it, but some code somewhere that literally just calls a number of functions on a number of interleaved subsystems. Like there's nothing keeping you from just writing that code, or having kind of the idea that a number of dependent processing in actors or components that are scheduled in some sort of tick group could call into a subsystem and have that subsystem do a thing at the right time for them. It kind of really depends on the specifics of what you're trying to accomplish for me to kind of give the suggestion I think would be best in that case.
All right, Mike, perhaps we'll get a follow-up
Yep.
as we go through the rest of the ones. So this person was wondering, so subsystems are like components on an engine level?
Yeah, they very much are, and that's why they're not a replacement for components, right? Components are components of actors, right? Whereas subsystems are sort of like a component of the different lifetimes. So a component of the engine or editor, game instance or local player or the world. They're not called components. We didn't want to have that confusion.
Yep.
Components, terminology-wise, tend to be very, very tied to ECS systems, entity component systems, object component systems. So we steered away from that naming, but for all intents and purposes, yes. But that said, components are a pretty high-level idea, right? The idea of componentizing, right, any functionality.
Composition.
Right, so I mean, that's exactly what they are, and they work very well that way, especially with plugins and modules and things like that, where including, the code in, plugs in those components to the right places, and then you get that set of functionality. So that's very astute.
Are there ever several instances of the subsystem?
In the cases of like local player and stuff like that. So only for lifetimes that have multiple instances. So game instance, well, game instance is again a little bit complex, but in one game, there's only ever one game instance. So there's only one. They're basically singletons. There are, in local player, you might have multiple local players, and there would be one subsystem each. So if I had like my personal stats subsystem, I'd put that on local player, and that's where I'd count up how many, points I got or whatever. Like obviously in my game, I use game instance subsystem for the score subsystem. But if I want to make this, couch co-op or something, I could put one on both local players, and they could score separately. Or I could make my my score subsystem be game instance subsystem, and I pass in the scoring player into the API that I make, so that internally it can track multiple players, and that might be better if you want them to be tied together. Like you want to have, be able to look at the score of both players separately or together, or be able to munge the data different ways. Then it might make more sense for it to be one subsystem that happens to organize its own data store for
maybe using a TMAP or something to.
Yeah. Or you can even have, a hierarchy of things where it's like you have a local score subsystem on each of the local players that stores data, and then you have a global score system that knows about those other subsystems, and they register in, and then it fields the data from them. You can go as crazy as you want. It really kind of comes down to the complexity of the system you're writing, right? Like anything, as something grows, the value of being able to split it up into different parts grows as well. So. That's kind of up to you based on the complexity. The one other case where you might sort of have multiple instances of subsystems is subsystems don't have to be leaf classes. So you could create an abstract class, and you'll have to mark it as abstract, otherwise it'll be instanced for you. But I could create we don't do this currently in our code, but we could adapt it to be this way. But for example, source control. There's Perforce and GitHub and all these other things. I might want to have a base subsystem that defines a bunch of API, and then each of those different source control systems would implement a concrete version of that subsystem, and then you would get one subsystem per source control type. That's one example of a case where you might actually have multiple of the same type. There's only one of each leaf level type, but there's, for all intents and purposes, multiple of the base API, and there's API on all the things that provide subsystems. There's a list-based one where you can get all the subsystems of type and pass it to type, and it would give you all of them back.
It's really nice. Yeah, we definitely got a couple more here, so let's keep going, yeah?
Yeah, absolutely.
All right. Let's see. Oh, I guess we might just have covered this. Is it possible to have multiple instances of a subsystem, or are they intended to be more like singletons?
Yeah, just to reiterate, it just depends on the lifetime. So, like I said, game instance ones are effectively singletons, except in multiply. That's the one kind of caveat there, that there are multiple game instances when you're in multiply. But yeah, they're effectively singletons for game instance. Editor and engine ones are definitely singletons effectively. They're not actually real singletons in the C++ coding sense. They're still an instance class that has a lifetime of stuff, but they're, for the most part, set up once and only thrown away when the editor goes away or the game engine goes away. And those can be useful, especially editor ones. Obviously, you're doing extensions to the editor and you want some system to manage something. Engine ones, would be fairly useful, especially if you're writing a plugin that adds some sort of lower level functionality to the engine, something that you would want to work in editor and in game, or in editor and in game, as opposed to something that's in game instance, which only exists when the game instance exists. So, for example, if I stop pi here, right? Stop pi, my subsystem's gone. It just got destroyed, right? Because the game instance that was running in that pi window got destroyed, and in turn, all the subsystems got away. If I had an engine subsystem, it would still be around. So you have to decide what you need. That has problems, right? If you're working on a game, you probably don't want to make engine subsystems, right? Because you don't really want, because I would run pi here again, and my engine subsystem would still be around. I'd have to worry about data polluting back in. But maybe I have something that's low level enough, like I'm managing save files, and for whatever reason I want it to be an engine subsystem because I want to be able to cache that data for the next run, just to make pi start up faster or something. There are reasons, and especially if you're writing lower level engine features. But when you're thinking about game functionality, you probably want to avoid
maybe more using a save game object or
there's definitely constructs for some of these things that are probably more direct. But I was just thinking of something that might have value in living beyond pi that's sort of game centric still. But
maybe for a virtual production or another sense when you're usually working in editor.
And in those cases, they're often using the editor itself. So even an editor subsystem might work there. But yeah, there's a lot of different use cases for sure, and that's kind of like why we have, I mean, was it 5 or 6 now? Yeah, five different lifetimed ones. So
Can subsystem be replicated? Can it be shared between server and client?
not intrinsically. Replication is something that's kind of actor centric, which is, maybe something that changes, in the future. But as of right now, you're basically your replication only happens on actors, so subsystems can't naturally replicate. It's something that maybe we look into, but it's certainly not on the roadmap currently. So right now, with respect to replication, you would definitely need to kind of forward a lot of that stuff through a replicated object to get that type of functionality, which is unfortunate for sure. It's not the cleanest one. But if you go back to like the types of things that have subsystems currently, most of those aren't things that actually live on the server anyways. Local players only live on the local client. Game instance only lives on the local client as well. So editor and engine, obviously those ones live everywhere. But so there's options there, either by using other things as your kind of transport mechanism for that type of stuff, or just doing a bit more manually within your subsystem. There's no reason why a subsystem couldn't listen for world creation, create an actor, and then utilize it as a transport layer. Like, you don't have to. You can still hide away all the complexity, avoid having to, you need to go make special actor in level, otherwise game doesn't work. You don't have to worry about that type of stuff. You can still kind of do it all. But yeah, there's no intrinsic replication support in subsystems currently.
See, is there going to be a good tutorial on making the code to create these subsystems? I would point you to the documentation. There's
a bit there, yeah. I think that this example is we can kind of show that code again if we wanted, but let's bring it up. But yeah, it's pretty simple. Right, it's just a U object in this case, but you derive from a particular class. The tutorial on the website, just search for Unreal Subsystems, and it's basically going to be your first link. Kind of takes you through the different lifetimes we have. As I just mentioned, UWorld's not on there right now, but it's basically the exact same thing. You just now you go from UWorld subsystem, and from there it's just a class. Other than the initialize and deinitialize, there's very little API. We can actually just jump up here real quick. I mean, oops, that's not what I wanted to do. Oh, we don't have IntelliSense here. Sorry, not IntelliSense, but whole tomato installed. Well, in any case, I can just talk through it. But U subsystem has very little API relatively. So the only other real piece of API it has, and it has a default implementation, you don't have to worry about it, is should create subsystem. And that's handy for some things. Like, for example, you might not want to create a subsystem on every client for some reason, or you might not want to create it on, if I was making like an engine subsystem for some reason, but I only wanted it on clients and not dedicated servers. I could basically say if dedicated server, basically return false, so it won't create that. It gives you a way to override creating subsystems or write some rules about whether or not it creates subsystems. You could even have like a subsystem that, imagine you had a bunch of dependent content in your plugin. You could write some check conditions about I have to have this, all this stuff, all these preconditions need to be met before I say, yes, I'll make the subsystem. You probably want to throw out an error there because users are going to be like, well, where's the subsystem? Why isn't it working? That type of thing, but you might want to do that type of stuff. And then the one other thing that's interesting with this API, just since we had it up, is the collection base is passed in here. So basically that's there for a very specific reason. As you use subsystems and create more and more subsystems in the game, you're going to start running into the dependency questions, right? Oh, well, I need my source subsystem to initialize before other subsystems initialize. You're going to get some of that automatically based off of the lifetimes you chose. So, for example, game instance subsystems are always going to be initialized prior to world subsystems being initialized because it comes into existence before the world does. So you get a bit of that, but you might want to be able to control your initialization order. So what you can do is basically call the collection, be like collection dot initialize dependency, and then it's a templated class based on the type. And basically what you're saying is, hey, subsystem, go initialize this first. So it's actually kind of a reverse sort of thing. You're not defining an order so much that you're defining your dependency inside your initialization, and then and then it'll basically recurse down into all the dependencies, do all those. So you do that early on in your initialize, and then you do all the stuff that depends on them, and you'll be in good shape. So that's why that's there. In simple use cases like this one, there was no value of it because I just didn't. I don't have any other subsystems in this thing, and certainly none that Score subsystem depended on. So, but that's there for you guys to use.
You think we'd be able to share the project files?
Yeah, sure, absolutely.
Yeah. We'll make sure to put it up on the forum afterwards.
Yeah.
Nice, thank you.
Yeah, no problem.
Let's see. Oh yeah, questions are coming in, so that's great. Fairly new to C++, but subsystems seem like good replacements for manually exposing C++ only code in Blueprint. If so, when do they not replace manually exposing C++ code?
I think that's a great use case. I mean, it kind of depends on what you mean by manually exposing. I'm guessing the user here means that there's something that we didn't expose, right? There's a lot of that. Just stuff that's in C++ that we don't expose because we just never got to it, didn't see the value in our use cases, or maybe there's complexities in it that make it not able to be exposed easily. Writing a subsystem, creating your own functions that kind of effectively wrap that or whatever. I mean, great use case of a subsystem. You could also use Blueprint libraries to do that, but again, the subsystem it houses that functionality. So if you have a number of different things, or you want to have a system that does a bunch of stuff and happens to also expose those things, because that makes sense in that context, it gives you better organizational tools. If you're just kind of blindly exposing a number of utility functions or something that they do, maybe Blueprint utils our Blueprint library would be the way to go for that. But I think subsystems would be great too. The thing with subsystems is that, I mean, they're a full class with state and everything. I mean, Blueprint libraries are as well, but they're effectively meant to be stateless because they're just effectively supposed to be static exposures and stuff. So in this case, it's like these are entirely meant to be a stateful system. So like my score system tracks the internal scores, for example, and that's totally reasonable. And if there was some extra functionality of the engine, I'd just have access to it here because I'm in C++, first of all, but I could expose some score subsystem that effectively wrapped some underlying engine functionality, if that made sense. So yeah, that's totally a valid use case of it, especially when you're linking that with other things that make sense, because then you get that encapsulation of get my subsystem, then I see in a very kind of short form way all the functionality that's there, as opposed to kind of like that very sort of busy sort of global namespace.
Awesome. And they were asking, is there any way to organize the order of initialization? We covered that using the collections.
There isn't really, you can only, just a bit more clarity on that one. You can define dependency by saying, in this particular case, I would take the initialized code, I'd say collection dot initialize dependency, and then the subsystem one initialized, and that would work fine. That only works within one collection. So one collection being one lifetime. So everything that has a lifetime has a collection of subsystems somewhere, so game instance has a collection of subsystems. That's what drives the whole system. So what I can't do is say, oh, game instance depends, initialized dependency of a world subsystem. That would not work. But you can't do that anyways, right? Like, you could have a world subsystem use a game instance subsystem, right? That's fine, but you can't declare it as a dependency because it's not part of the same collection. You can use it just fine because you know that the initialization order is the way you want.
Yeah.
But if I try to do something the other way around, that wouldn't work. And it doesn't work in general because a game instance, what world are we talking about? It doesn't know. There's no. Whereas game instance is kind of like a thing that owns worlds, as it were. Worlds don't. Worlds don't own game instances, so you can't really do the other direction as a dependency. So you can reference in that direction, but you can't depend in that direction. So it would be kind of poor architecture trying to do that anyway. So, so it makes sense that you can't really do it.
Let's see. Sorry if this was covered, but can subsystems store asset references or properties accessible from content browser, like data asset?
Not. I mean, okay. So, I mean, yes, you can kind of force it to do that, definitely. But generally, we try to avoid defining data references in code. There are few examples of it around, but Generally, you try to avoid that. You're creating a fully quantified path, and it's textual, and it doesn't respect if you move assets, so
Yep.
it's generally bad. So generally, what I suggest in those cases is you have. What I would do is I would create like a data asset that had a bunch of stuff in. So you define like a ustruct data asset, or just another use class, or maybe a blueprint, something you intend to make a blueprint class of. Depends on what you do want to do with the data side. Like blueprints gives you data inheritance if you want to have more complicated stuff. But in any case, you have some asset that defines all that data based off of a structured set of data defined in C++. So I have my data class that says, have int1 and int2. I inherit that or create a data asset of that type, or inherit it in a blueprint, depending on which one you want to use, and then you define that data. And then in your initialization, probably in, let's say, begin play of your level, or in the initialization, you have like some callback that something else listens to do it. But anyways, you find some place to basically say, hey, subsystem, here's your data asset, and you pass it into it, and then that subsystem goes and initializes, pulls out the data it wants, or holds on to it to look at data later, that type of thing.
And then just make sure you do that before you're actually trying to.
Yeah. So then it comes down, you do have to deal with a little bit of work there,
Yeah.
obviously, to figure out like when do I set that initialization. But you're just gonna be in a better state there, like referencing data from C++ is something to be avoided, just because there's no hand holding with it. Like you're gonna, first of all, you have to figure out how to make a fully quantified path correctly, which is not hard, but sometimes not intuitive, and then you're just going to have possible bugs that come out of that. So yeah, I mean, most larger games I've worked on do exactly that. There's some large data store classes that reference a bunch of stuff, and then it's like my games settings or my games references or whatever, and then you pipe that into systems that need it. Sometimes you just have like a global accessor, because that tends to be this kind of monolithic thing. I actually don't suggest doing that. I suggest splitting your data more. Also use weak object pointers, not hard references, because that'll mean that you actually load things on
I've been
demand.
planning to do a live stream on that actually, and the difference in how to use it in blueprints.
It's harder. I mean, you have to deal with more stuff, but it really depends. If you're working on a small project, it's generally not that big a deal. But you think of something as large as like Fortnite with hundreds of thousands of assets or whatever. Like obviously, if you hard reference all those, you'd have to load every single one when you loaded the editor, and that would be waiting 30 minutes to start editing a thing. No one wants to do that. So you have to be careful about that. And weak references, using those by default, even though it sometimes means that you have to sort of write the hooks to say, okay, time to load this set of things, is better engineering, especially when you're talking about a project that's going to scale up larger.
Can subsystem objects be serialized/deserialized?
Yep, they're UObjects, absolutely. I mean, it's the same thing as anything else. Transient variables won't get, if it's not a U property, it won't get serialized. If it's transient, it won't get serialized. So all the same rules apply as U properties. They're just UObjects. And the same thing actually goes with the blueprint exposure, right? Obviously, I made all these in this example here U functions because I intended them to be called from blueprints. But if you have functions that aren't U functions, they won't be accessible in blueprints, which can be nice too, because it kind of gives you 3 layers, right? And this is the same with any blueprint. This is not special to subsystems, but I have U function things that are exposed. That's kind of like a 1 layer of accessibility. I could have public things that only C++ could get at. If I had, let's say I wanted some C++ subsystems to get at some API that I want to be public, but I don't want sort of my artist designer type users to see them because maybe they're confusing or not something that we want to use at runtime, and there's a very specific call pattern, who knows. And then you have private, of course.
What is the difference between singleton inherited from UObject, parenthesis, added all function blueprint callable and delegates, and subsystem?
Can I read that one?
Yeah.
That's fine. I just want, you kind of quoted it, I wanted to make sure that, what's the difference between, I think I understand what the user's asking, and I think the answer there is not a whole lot, except for all the utility that the subsystem's giving you, right? I mean, as far as the functionality goes, a UObject's a UObject is a UObject, right? U functions work the way U functions do. U properties work the way U properties do. But getting at it is where like the extra, work might come in, right? Like subsystems are giving you those nice blueprint nodes to be able to get them by type and They're giving you that. They're giving you the fact that they're auto instance. They're giving you the fact that they have different lifetimes and they have initialize and deinitialize. It's basically all that stuff. Just a regular UObject singleton, just doesn't give you any of that framework. And I'm not saying that the framework for subsystems is actually that complicated. It's relatively simple. There's some extra complication, especially when it comes to editor and engine subsystems, because those are dynamic subsystems, so they actually can be loaded late based on module loading stuff. It's a complexity I didn't really want to get into, but there's a bit more going on there. Whereas with local player and game instance subsystems, they are, if the subsystem doesn't exist, when they get created, they never get created. So if you late loaded a plugin or something, it would not get created in a pre-existing game instance. So you'd have to stop and start Pi. That said, you can't change plugins without restarting the editor. It's just not a problem you'd run into, but kind of in a more generic sense, there is a bit more going on with engine and editor subsystems because of this ability to be latently loaded. But for the most part, I don't think users have to worry about that too much. But yeah, it's all those little bits of convenience that we get. And the fact that you're not explicitly writing in dependencies when you need to initialize things. That's one of the big benefits. So if I had 20 subsystems of different things in my game, and if I could write all the subsystems like in the old world before subsystems, I'd still write 20 subsystems if I was encapsulating my functionality in a nice way. They wouldn't be subsystems in the sense of this new stuff, but then I'd have to come along and I'd be like, okay, I'll derive from my game instance and be like, my game instance derives from base game instance, and then I'd create an instance of every one of my subsystems. And now what I've created is this class with basically dependencies on all that stuff. That's not the end of the world. My game does depend on all that stuff, but now I've defined that, I've hard coded that, right? And if those were in plugins, well, now I have a thing that references that directly, and if I didn't want to load it, I would have to change the code itself if I wanted to disable the plugin. So the fact that they're auto-instantiated just based off of the existence of the class in the type database means that you don't end up with these hard references of things, and you don't end up with that kind of spaghetti of dependencies in classes, in those shared classes. So it allows you to break up your game more. And really, like I said, really helps, especially in the plugin case. The bottom line is your game's probably not going to remove its score system anytime soon, right. So you're not too worried about the cost of changing that code if you decided to remove it, because that's a one-time cost. It's small, but the case of I'm trying to make plugins, maybe I want my score system to be used. It's so good. You guys saw it. It's got multipliers. It's got adding score.
Yep.
It's pretty awesome. So I definitely want that in every single one of my games. So now I could put that in a plugin and move it from game to game. Obviously, you guys will make much better subsystems that actually have a lot more value to move. But it's especially nice, if you want to distribute stuff or share things in the marketplace. I think it's an amazing tool for creating encapsulation within a game, ignoring all that stuff, but it's almost needed, if you really want to make a really easy to use plugin.
Yeah, for someone like me who almost 99% of the time I use Blueprints to script all my game logic, I can understand this.
Yeah.
I don't have to deal with initialization and all that, right? It's sort of like, I can actually go ahead and write a subsystem and encapsulate some of my functionality here, and it doesn't even seem too complicated.
One of the users actually mentioned, I'm new to C++, right? And it's like, well, look at this code. It's not that hard to write. It's pretty simple. If you can write some C++, you can basically write this. You have to learn a little bit of epic magic with function property. And I think your new user to C++ could write this class pretty easily and make a sweet little score game just like I did. But what that user probably can't do, being new to C++, is figure out in the million lines of Unreal 4 what class they would have to derive from,
right,
and where they should initialize their subsystem. That's not that hard if you know Unreal well. But when you're just starting, you don't know that type of stuff. And this helps, I think, just avoid having to learn those things. Don't get me wrong, I want everyone in the world to become an expert of Unreal and know all the ins and outs and all that type of stuff, but let's be realistic. Everyone wants to make a game first, and I think this helps you to some degree avoid having to learn things that you otherwise don't need to.
It's easy to get unmotivated as well when you're just in the trenches and you don't necessarily see any progress, right?
Yeah.
And so having that game idea is...
I'm a tools engineer, so
yeah.
I go home to write a game, and before I know it, I'm writing localization systems, and then I question what I'm doing with my weekends. But the game always seems to fall by the wayside, and other things sort of...
But that might be the catalyst, right?
Absolutely.
For you to get into tools. It's like, let's make a game where I discover which tools I need to make it,
Absolutely.
and then you'll just focus on the tools.
Well, almost every tool came from trying to make a end product, right? It was like, oh, I was, the first time someone wanted to make big levels, right? That's where the first level editor came from,
Yeah.
right? It was like, it's always kind of, tools come as out of demand, right? I want to do more things. I want to do more something this, and tools derive out of that because, you need to ease, the workload of doing those new things. So, what else we got question-wise?
Yeah, we got a few more. We still have a little bit of time. We covered a little bit of this, but I think it's worth repeating. Once you create a subsystem, can you access it from anywhere in code? Is there like a global getter?
Oh, that's a good question. We talked about it. I said yes, you can get them from code, but I didn't really describe it all that well. It depends on the lifetime again. So in Blueprint, you have the nicety of that context I was talking about. So we have a number of Blueprint functions that kind of take care of that for you and make it really easy. So I'm in a widget Blueprint, for example, and I just say get the score subsystem. Well, what's really under the hood happening is that the widget blueprints are actually owned by a player controller, which lives inside a game instance, and the game instance has the collection that I get that subsystem from. So there's a little bit of plumbing that's been done for you. You kind of have to do that yourself in Blueprints, in C++. So in C++, depends on where you are. A component would probably get its UWorld, get the game instance that the UWorld lives in, and then there's this API get subsystem. They're just templated functions. So there's get subsystem, there's get like subsystem list. We don't expose the list API, I don't think, in Blueprint at all. Maybe we add that. We have 0 examples of list-based ones right now that are actually needed. It's definitely something that was meant more for fleshing out multiple implementation APIs. Like streaming would be an interesting one. If we added streaming functionality, you might have Twitch and you might have YouTube, right? And those would be 2 different implementations of some base streaming API that both lived at the same time, and you might want to talk to both of them or one or whatever. So that's one example. But in C++, you need to be able to get at the context object. So depending on what it is, game instance is probably one of the more likely ones. UWorld is probably another likely one. But yeah, getting a UWorld from an object is really easy. Getting a game instance from player controllers, from UObjects and from worlds is all really simple. There's a lot of different means to get at those things. So that's generally pretty simple. You have to get the context object called get subsystem. It's just a templated function.
Had a question about examples. I think we covered quite a few examples already. Checkpoints, pooling systems, score systems. And then we have a question, someone's asking what the difference between a data asset and a struct is.
A data asset and a struct? A data asset is, I think, a U class. I'd have to look it up. They're not much different. I mean, a data asset basically is, the only real difference is that a data asset the editor looks at and allows you to create those as an asset and serialize them in and out. In the end, they're just a bucket of properties, right? So they're the exact same as a struct in that sense. They're just a bucket of properties, with values, whatever. But a data asset, when you derive from a data asset, like the editor knows, oh, data asset class, that's a thing that we put in menus for you to be able to create. We and in turn, you may end up with assets of them that exist, right? So really, it's just important that there's some plumbing in the engine that says, data asset. Okay, well, I'll allow a user to create an instance of that and serialize it out to disk and back in and stuff like that. That's really functionally the only real difference there.
And I believe that was our last question.
Cool.
We covered quite a bit there.
Yeah, I talked a lot.
That's why you're here. We want to hear you talk, and we want to hear everything that's going on in your mind. Someone who actually worked on the system and implemented it and knows why it's important, the use case for it, and why you wanted it and why you wanted.
Yeah, and I think that kind of comes back to the one user's question. It's like, aren't subsystems just like components for different things? I'm like, yes, they are. I'm a big proponent of componentization. I think it's just, it kind of checks a lot of the boxes of just good engineering, right? Keeping things encapsulated, keeping the dependencies down as much as possible, providing clean APIs by saying these are the public things you're allowed to access. Here's all the implementation details you shouldn't need to worry about, keeping those separations and stuff like that. And componentization in general and subsystems in turn just lean into that. And it's all about keeping your architecture clean, thinking about what is the functionality that should live in one place, what do I want to be public and what is hidden, and that's why we created subsystems. It was to enable more of that, and because you can do that still, right? Like even before subsystems came, you could write code that way. It was easier to do it the wrong way. Subsystems was really about making it easy to do it the right way, right? So if I derived from game instance, I could drop some API in game instance and then be done. Or I could derive from game instance, create my score manager, create an instance on that, new up that instance when it initializes, pass through whatever I need to, then write my API over here in a nice, encapsulated place, which was the right way to do it. That was the good way of doing it. But the description took 3 or 4 times as long because it was more complicated. It's not a lot of code. It's not extremely difficult, but it's just a bunch of boilerplate, right? So subsystems was all about saying, okay, well that's the right way to do it. Let's make that the easy way.
Yeah.
Right. So now you derive from a single class, write your code, you're done. Honestly, creating the files and adding them to the project kind of takes more time than anything else at this point, because you're really talking about just public my class : deriving from game instance, right? Like, so that was really the main goal. It was like making the right way easy.
And then there will be hopefully less problems.
Yeah. The hard thing is still in everyone else's hands, right? The hard thing is defining what subsystems I'm going to have, what API those are going to have, how I'm going to implement it. The hard stuff is still there, but hopefully it also empowers sharing of stuff more as well, which I think is because of its natural affinity of working very well with plugins. I think that's going to allow people to make more easily shared
and
stuff.
I've seen it. I think even in the first preview release of the subsystems, the VR expansion plugin developer immediately moved over. He's like, oh yeah, this is just going to be a subsystem.
Right, because I bet anyone who's written a plugin for the marketplace who has a bunch of people using it almost certainly has written the little document that's like, okay, here are the things you got to go do to put this thing into your game, right? For just like a content only thing, it's not that complicated, right? Download the plugin, put it in, and now you have content that you can reference. But when it comes to code and stuff like that, you have to have that little kind of like to do, download step 1, and then step 2 through 10 of kind of just hooking up the little bits of plumbing. Again, not that complicated, but better if you don't have to do it.
Yeah.
So I think it's going to really help there. I think that's like a great. And anyone who's had to write that and then deal with a bunch of people online who made some minor mistake along the way and it didn't work properly, and no one wants to remote debug. So I can see why someone who writes plugins would be like immediately like, yes, I want that because now I don't have to deal with all that stuff. So.
That's great. Thanks so much for coming here.
Awesome. Thanks for having me.
Yeah, it was. I learned a lot. I hope all of you guys learned a lot as well. Couple of notes before we take the stream offline. We are doing transcripts of all of the live streams, and so if there was something that we mentioned here today that you remember that we talked about, but you don't really remember where. We've been here for an hour and 13 minutes now, so we've said a lot. So I know that can be tricky. In usually about a week after the stream, we upload a transcript to YouTube. It's a link in the description. You can open that. It's a PDF, and you can Control F and search for keywords. And what's nice about that is that if you find the keywords you're looking for, you can see the timestamp right next to them, and you can go to the part of the stream where we discussed it.
That's great. Just don't hold me responsible for everything. I do make mistakes.
we all do. And usually about a week, and we are doing that. We're backlogging that as well, and so we're trying to get most of the streams from the last at least year and a little bit further back. And that the transcripts are used for the captions, but there's also a nice use case of them where you can actually go and search for what we talked about. There's also a cool feature on YouTube where you can actually see it in real time. So not only if you don't like the captions overlaying the screen, especially when we're working in editor. That can be a little annoying. You gotta go toggle them on and off. You can actually enable an option to see them on the right side, right above chat, I believe. So if you're watching the the VOD, and then you can also click them to go to the specific sentence. So something like to mention, I know I've been using the transcripts quite a bit. We always have a survey that we put out. Please let us know how we did, what you would like to see in the future, and if you participate and you put your email down, we do a sweepstake where we send out a T-shirt to one lucky winner. I need to hear what you guys want to see so that we can actually bring you the topics that you're interested in. Make sure you visit our user group page, unrealengine.com/user-groups, if you're interested in meeting other developers in your area. If you don't find a user group and you have a group of people who are interested in going to a UE4 specific meetup, contact us at community@unrealengine.com, and we will talk to you about everything that it is of becoming a meetup, a user group lead. And we got some more news coming there real soon, which we're going to be excited to share with y'all. Go visit our online communities, forums, the unofficial Discord channel. I think it's up to 27,000 members now. It just keeps ticking. Good job, Nick, and everyone else who is running that. Our Facebook page, as well as Reddit, there are tons of UE4-related content that you can go and look for, or ask questions when you have problems. The community is happy to help, but remember to try to give as much information as possible in your question. If we don't have that, maybe someone would know the answer, but the question is just not enough, and they won't have time to sort of try to get to the real question. So try to bring as much information possible. Just little tips. Our community spotlights that we have every week, please go ahead and send everything you're working on, your projects. The forums are a good place to put that, released projects as well as the work in projects part of it. I like to go and look there and see what everyone's working on. We're still looking for more countdown videos, and they are 30-minute videos, sped up to 5 minutes. So send that to us together with your logo separately. Don't embed that in the video. We will take care of that for you, and then we might go ahead and have you as one of our countdowns. That was the 5-minute thing we saw in the beginning, the countdown.
Yeah, it was cool. It was like building like a Roman-style sort of architecture, a little dilapidated, but it looked really cool.
Yeah, and there are a couple of really cool ones with some people working in sequence there, and you get to see like tidbits of their workflows, which, and it's sped up to 5 minutes. So
it's always amazing to see you see the same parts coming in over and over and over, and just with the artist just like scale and change them, and it turns into something completely different. It's really awesome.
I wish I was a better artist. My products would look a lot better then. I wouldn't need to ask for help. If you're streaming on Twitch, make sure you use the Unreal Engine category so that we can tune in. And as always, follow us on social media, and special thanks to Chris today, who were able to come on and talk to us everything. If you have more questions, go ahead and ask them in the announcement post on the forum. And if we have time, and if possible, we'll try to go ahead and answer your questions there. All right, next week, we actually have Matt Workman coming to talk about Blender to UE4 workflows. Matt Workman is the developer of Cinetracer. You might have seen him around on the web. He's creating a lot of very cool content, as well as his tool to stage and previs cinematic sets. So he'll actually be here in the studio next week. Very excited to have him. But until then, bye-bye.
There, guys.